In this video, I'm going to explain AI algorithms and their application. There are many AI algorithms used in machine learning and artificial intelligence. AI algorithms are the building blocks of artificial intelligence and they are used in a wide range of applications. Here are some of the most common AI algorithms and their applications. Supervised learning algorithms, unsupervised learning algorithms, reinforcement learning algorithms, evolutionary algorithms, deep learning algorithms, expert systems, Bayesian networks. Now in this video we'll discuss one by one these algorithms and their applications. Let us first will see that supervised learning algorithms. Supervised learning algorithms are a type of machine learning algorithm that involves training a model on labeled data to make predictions or classifications. Here are some of the examples of supervised learning algorithms. Linear regression. This algorithm is used to model the relationship between a dependent variable and one or more independent variables. It is often used for predicting numerical values such as housing prices, etc. Next, decision trees. This algorithm builds a tree-like model of decisions and their possible consequences. It is often used for classification tasks such as predicting whether a customer will blend or not. Next is random forests. This algorithm is an extension of decision trees that builds multiple trees and combines their predictions. It is often used for classification tasks and can handle complex data sets with many features. Next is support vector missions SVMs. This algorithm finds the optimal hyperplane that separates the classes in the data. It is often used for classification tasks and can handle nonlinear data sets with high-dimensional feature spaces. Next one is neural networks. This algorithm is modeled after the structure and function of the human brain and consists of layers of interconnected nodes that process information. It is often used for both regression and classification tasks and can handle complex data sets with many features. Next is the naive Bayes. This algorithm is based on Bayes' theorem and assumes that the futures are independent of each other. It is often used for classification tasks such as predicting whether an email is spam or not. Next is K nearest neighbors KNN. This algorithm classifies data based on the majority class of its K nearest neighbors in the feature space. It is often used for classification tasks and can handle nonlinear data sets with many features. So these are the few several the applications of supervised learning algorithms. Next we'll see that unsupervised learning algorithms. Unsupervised learning algorithms are a type of machine learning algorithm that involves finding patterns and relationships in data without the use of labeled data. They work by finding patterns or similarities within the data and grouping them accordingly. Here are some of the examples of unsupervised learning algorithms. One is clustering. This algorithm groups similar data points together based on their similarity in the feature space. It is often used for customer segmentation or image segmentation. Next one is principal component analysis. that is PCA. This algorithm reduces the dimensionality of the data by projecting it onto a lower dimensional space while preserving as much of the variance as possible. It is often used for future extraction or a data visualization. Next is autoencoders. This algorithm consists of an encoder and a decoder that work together to reconstruct the input data. It is often used for dimensionality reduction or anomaly detection. Next is association rule mining. This algorithm finds patterns and relationships between different items in the data set. It is often used for market basket analysis or recommendation systems. Next is generative adversarial networks, GANs. This algorithm consists of generator and a discriminator that work together to generate new data that is similar to the training data. It is often used for generating realistic images or data augmentation. Next is self-organizing maps, SOMS. This algorithm creates a low-dimensional map of the data set by preserving the topological properties of the data. It is often used for data visualization or clustering. Next is hierarchical clustering. This algorithm groups similar data points together in a hierarchical tree-like structure. It is often used for visualizing the relationships between different data points or for creating taxonomies of data. So these are the few of the examples of unsupervised learning algorithms. Next, we'll see that reinforcement learning algorithms. These algorithms are used to train agents to make decisions in an environment. The agent is given rewards for making good decisions and penalties for making bad decisions. So over time, the agent learns to make better decisions to maximize its reward. The reinforcement learning algorithms are a type of machine learning algorithms that involves learning from rewards or punishments received from the environment. Here are some of the examples of reinforcement learning algorithms. First one is Q-learning. This algorithm learns an optimal policy by estimating the value of each state action pair. It is often used for solving control problems in robotics or game playing. Next, SARSA, SARSA. This algorithm learns an optimal policy by estimating the value of each state action pair, taking into account the action that was actually taken. It is often used for solving control problems in robotics or game playing. Next is deep reinforcement learning. This algorithm uses deep neural networks to approximate the value function or policy function. It is often used for solving complex control problems such as playing video games or driving autonomous vehicles. Next is actor critic. This algorithm combines the advantages of policy-based and value-based methods by having a separate actor network to choose actions and a critic network to estimate the value of the current state. It is often used for solving continuous control problems. Next is Monte Carlo methods. This algorithm learns by sampling episodes from the environment and estimating the value of each state based on the returns received. It is often used for solving problems where the dynamics of the environment are unknown or stochastic. Next is temporal difference learning. This algorithm learns by updating the value function based on the difference between the estimated value and the actual reward received. It is often used for solving problems where the dynamics of the environment are known. Next is policy gradients. This algorithm learns by directly optimizing the policy function using gradient ascent. It is often used for solving problems with high-dimensional action spaces, such as in robotics or game playing. So these are the comes under reinforcement learning algorithms. Next, we'll see that evolutionary algorithms. These algorithms are inspired by the process of natural selection. Evolutionary algorithms are a type of optimization algorithm that are inspired by the process of biological evolution. They involve generating a population of candidate solutions and then using evolutionary operators such as mutation and crossover to create new solutions. Here are some of the examples of evolutionary algorithms. One is genetic algorithms. This algorithm generates a population of candidate solutions and uses selection, crossover, and mutation operators to create new solutions. It is often used for solving optimization problems in engineering and design. Next, particle swarm optimization. This algorithm models a population of particles that move around in the set space, influenced by their own best position and the best position of the swarm. It is often used for solving optimization problems in engineering and design. Next is ant colony optimization. This algorithm models the behavior of ants searching for food and uses pheromone trails to guide the search. It is often used for solving optimization problems in transportation and logistics. Next is the differential evolution. This algorithm generates new candidate solutions by combining the differences between randomly selected solutions in the population. It is often used for solving optimization problems in engineering and science. Next is evolution strategies. This algorithm generates new candidate solutions by adding random noise to the current solutions and selecting the best ones for the next generation. It is often used for solving optimization problems in robotics and control. Next is cultural algorithms. These algorithms combines evolutionary operators with a cultural evolution process that learns and adapts to the problem environment. It is often used for solving optimization problems in complex systems such as social or economic systems. Next, artificial immune systems. This algorithm models the behavior of the immune system and uses antibody and antigen mechanisms to search for and recognize optimal solution. It is often used for solving optimization problems in data mining and pattern recognition. Next, deep learning algorithms. Deep learning is a subfield of machine learning and uses artificial neural networks with multiple layers to extract complex features and patterns from the data. Here are some popular deep learning algorithms. They have been particularly successful in areas such as image and speech recognition. Convolutional neural networks, that call it as CNNs. CNNs are commonly used in image and video recognition tasks. They use convolutional layers to extract the features from the input data and pooling layers to reduce the spatial dimensions of the future maps. Next one, recurrent neural networks, that is RNNs. RNNs are designed to work with sequential data such as text or speech. They use recurrent connections to maintain information from previous time steps and can learn to generate sequences. Long short-term memory networks (LSTM). LSTMs are a type of RNN that can selectively remember or forget information over long periods of time. They are commonly used in language modeling, speech recognition, and video analysis. Autoencoders. Autoencoders are unsupervised learning models that learn to compress and decompress data. They consist of an encoder network that maps the input data to a lower dimensional representation and a decoder network that reconstructs the original data from the lower dimensional representation. Next, generative adversarial networks, that is GANS. GANS consists of two networks, generator and a discriminator, that compete with each other in a game theoretic framework. The generator learns to generate realistic data samples, while the discriminator learns to distinguish between real and fake data. Next is deep reinforcement learning. Deep reinforcement learning combines deep learning with reinforcement learning, a type of learning where an agent learns to take actions in an environment to maximize a reward signal. It has been successfully applied to tasks such as game playing, robotics, and autonomous driving. Next is deep belief networks (DBNS). DBNS are a type of neural network that consists of multiple layers of restricted Boltzmann machines (RBMS). They are commonly used for unsupervised learning and feature extraction. Next, expert systems. An expert system is a type of artificial intelligence that is designed to replicate the decision-making abilities of a human expert in a specific domain. Expert systems use a knowledge base, which is a collection of facts and rules about the domain, to make decisions or provide advice to users. These algorithms are designed to mimic the decision-making abilities of a human expert in a particular domain. The key components of an expert systems include knowledge base. The knowledge base contains the facts and the rules about the domain that the expert system is designed to work in. These facts and rules are usually written in a specific language that is easy for the expert system to understand. Inference engine. The inference engine is the part of the expert system that uses the knowledge base to make decisions or provide advice. The inference engine follows a set of rules to draw conclusions based on the input provided by the user. Next is user interface. The user interface is the part of the expert system that allows the user to interact with the system. This can be a text-based interface, graphical user interface, or voice interface depending on the design of the system. Explanation system. The explanation system provides the user with an explanation of how the expert system arrived at its decision or advice. This can help the user to better understand the reasoning behind the system's recommendation. Bayesian networks. These algorithms are used to model the probability of events based on known relationships between variables. They are commonly used in decision making and risk analysis. A Bayesian network is a type of probabilistic graphical model that is used to represent and reason about uncertainty in the system. It is based on the principles of Bayesian probability theory and uses a directed acyclic graph (DAG) to represent the probabilistic relationships between variables in the system. In a Bayesian network, each node in the DAG represents a random variable, and edges between the nodes represent conditional dependency between the variables. The network also includes a set of conditional probability tables (CPTs) that specify the probability distribution for each variable given its parents in the network. So the key advantage of Bayesian networks is their ability to reason under uncertainty. Given some observed evidence, the network can calculate the positive probability observation of any variable in the network, taking into account the probability relationship between the variables. So there are just few of the examples are mentioned for the different AI algorithms. So there are many other AI algorithms and the researchers are constantly developing new ones to improve the performance AI system. I hope all of you understand what are the different algorithms are generally used in artificial intelligence. Just I want to collected all the algorithms and presented here for the benefit of the readers or viewers. Thank you.